All right, so as the light continues to move down, we're going to have some of that light being diffused or spread, and we're going to be seeing that kind of in our sunsets as the light comes all the way down, has more atmosphere to go through. We have the light bending or refracting in mirages and rainbows, and then, honestly, some of that light comes all the way down as short wave. All of our visible light energy, remember, is in the short wave, or the SW, or light. That short wave light energy can come all the way down, and one of two things is going to happen next to that light as it comes all the way down. The first thing that can happen to that light is that it can be absorbed, or it can be reflected. Right? So what we're going to have is we're going to have two different surfaces. Right? Maybe we're going to have freshly fallen snow, and let's get a nice blue fresh pen for white, smooth snow. Okay? So that white, smooth snow is there, and the light energy comes down. The short wave light energy comes down. It hits that white, smooth snow. Now, why do I say white and smooth? Because this process is dependent on two things. Based on land, at least. Water is going to be different. We'll talk about that another time. But on land, it's going to be based on color and texture. Right? If it is white, a very bright color, and it is smooth, then what we will see is that most of that light energy is reflected. And so if we're looking even at it from space, we're going to see a lot of light energy, short wave light energy coming back up off the surface. All right, now let's take a look at something different, right? This time, let's look at a big old parking lot. So we're going to be looking at black asphalt. All right, and that black asphalt has the light energy coming down from the sun. So light, short wave radiation, coming all the way down through the atmosphere, and it hits that black asphalt. Oh no. Now what happens? Well, it's darker. Right? The light of it is actually, like when I look at it, the light's disappeared. It's black, right? Just like this pen. Oh no, the light's disappearing. Okay, it's reflecting off that one little, because it's a smooth surface, but the color, it's absorbing most of that. Creepy. Well, where's it going? Here's where it's going. This guy came up with this little law, the law of thermodynamics. And in it, he says, energy cannot be created nor destroyed. Oh, well, then what does happen to it? It can only be changed from one form to another. Well, thank you, Einstein. All right, so what happens to it? Well, if you go out there in the parking lot, it's going to be kind of warm because this light energy is absorbed. Okay. And then what happens is it starts to radiate as heat. Okay. That's the next guy over in the electromagnetic spectrum. Starts radiating off as heat. Okay. And that's going to be long wave radiation, or LW. So what we end up with is this heat coming up and off the surface. Now, this surface has different reflectivity. Reflectivity. Good. The reflectivity of the surface. There is a term that we want to learn that basically means the exact same thing as the reflectivity of that surface. It is called the surface albedo. Albedo. The surface albedo is the surface reflectivity. Okay, so if we're talking about the white smooth snow, it has a high reflectivity or a high albedo. If we're talking about the black asphalt, then it absorbs a lot of light energy, so it has a low surface albedo. Okay. We refer to this whole process of energy coming in and energy going out as Earth's energy balance. Okay, and what is it balancing? Well, it's balancing the light energy, shortwave energy coming in. Is it reflected or absorbed? If it's absorbed, then, well, if it's reflected, it just goes right back out as shortwave energy. If it is absorbed, then it is re-radiated as long wave heat energy. Okay, so the light energy oftentimes can go all the way back out through the atmosphere. This long wave heat energy, well, some of it does get stored here. Okay, and this is probably a good spot to talk just briefly about global climate change and global warming. See, this long wave heat energy can get trapped, okay? And that's going to be from our greenhouse gases. Okay, now some of these greenhouse gases are good. We do want to retain a little bit of heat energy because otherwise night versus day would have huge swings in temperature. And having some of this heat energy in our atmosphere is good. However, we've had an increase of our greenhouse gases. The big guys have been CO2. That's a result of fossil fuel. Another one is methane. That's a result of domesticated animals. And there's a few other ones that are going to be kind of nasties. But this guy from the burning of fossil fuels, CO2, we've increased the amount. So we want to be able to trap a little bit with our greenhouse gases. Water vapor is also one. That can trap a little bit, right? And having it trap a little bit is good, keeping things a little bit warmer. However, we do want some of that to escape back out. Okay? And if we increase these guys, okay, then what we end up with is a bigger shield of greenhouse gases. They're going to be retaining more heat energy, and less is going to be able to make it out. More will be trapped in here. And so sometimes we start to see this increase. Now, I've included a few other videos in the learning module that talk a little bit about this greenhouse warming and the greenhouse effect. But this is going to be kind of what we have with this Earth energy balance. So we do want a little bit of warmth coming from the surface, that light energy being converted into heat energy down here at the surface. However, we don't want too much to get stored.